Okay, so this is from a real SAT, and this is fairly easy, but the function f is defined by f of x equals 8 to the square root of x. And just remember that this square root bracket also means, like, if you have something here, and let's say you have like 36 over here, all you'd have to do is take this off, is throw this over here, and it would become 6. Okay? So, f of x equals 48, but you are tying in this for what value does f of x equal 48? Okay, so f of x equals 8 over the square root of 8. First thing we do is we divide each side by 8, so that's what we're doing here. You're dividing it, and you're dividing this. So what is this going to become? It is going to become 6 equals square root. Now you are throwing this over to the other side. And when you want to get rid of a square root that is here of an unknown, for this practice only, it's going to become 6 squared. Now, you don't see 6 squared over here, you see 6, so be careful, because this is your distractor. A lot of people are going to choose A because they're going to say that's what it was. That's not the right answer, because it is 6 squared. Remember, you are getting this bracket to go over here, so that is 6 squared. This bracket has to come off, so in order to take this off, you have to throw your square over here, so it has to be 6 squared. 6 squared equals x, and x is 6 times 6, so x equals 36, and the answer is C. Done. Simple question. Now, let me ask you this. If you see 48 over 8, remember, you've got to get rid of this bracket here, excuse me, not the bracket, you've got to get rid of, because you want to get rid of this so that you can just order as an equation. If you think about it, this equals 6 equals 1 over the square root of x, which is square root of x anyway. Let's suppose you don't really want to do it that way, and you want to be complicated, and you want to not divide by both sides. You'd have to cross multiply, and that would be 8 times 48, which would be 384, and this is 8 times 8, which would be 64. So remember, you're not trying to be complicated, but look, it's 64 square root x equals, you're getting yourself complicated. But, when you divide this 64 by this 64, you're going to get the square root of x equals 6 anyway. So I'm going to write this out on the other slide to show you this better, so that you don't get so confused. See, it's all jumbled here, so I'm going to do it on the other side. Okay? And just remember, you want to make sure you're getting rid of this bracket. Okay? So this is if you do divide, this is if you don't divide. So let me show you on the other slide what I'm talking about. Okay, so if you look here in the middle, we have an alternative method. But look, there's a cross here. There's a blue side and there's a red side. 48 times 8 is 384. So 8 times 8 is 4, carry my 6. 8 times 4 is 32, plus 6 is 38. So when you divide this, you cross this out. This is 1 over x, which of course equals x. Now, what does this become here? $64 into 384 Excuse me if anyone heard that. Wonder if it's 6. Let's try it. 4 carry my 2, 36, plus 2 is 38. So yeah, it's 6. Okay, so guess this. This is now going to be 6. And if you had an answer for the square root, this is why people are going to try to get 8, because they're forgetting they have to get rid of this bracket. And so x 6 squared is 36. So this is just an alternative method in case you didn't want to go through the trouble of solving, of dividing, and you just wanted to look. And remember, this means to divide. So if you cross multiplied, which is the inverse of action, you'd still get the same question. This was taken from an actual Scholastic Aptitude Test exam. And that's the answer. Okay, so let's start reading here. Given that stars and planets initially form from the same gas and dust in space, some astronomers have posited that host stars, such as the Sun, and their planets, such as those in our solar system, are composed of the same materials, with the planets containing equal or smaller quantities of the materials that make up the host star. The idea is also supported by evidence that rocky planets in our solar system are composed of some of the same materials as the Sun. So this argument is going like in a circle or round and round, like a lot of them are. Okay? So what you really want to do is you want to take a look at what's going on. The since stars and planets initially formed from the same gas and dust, host stars, and they give you an example, such as the Sun, and those that are in our solar system, and remember, solar means sun, they're composed of the same materials, with the planets containing smaller or equal quantities of the materials that make up the host star. This idea is supported, so you're looking for evidence that the rocky planets in our solar system are composed of some of the same materials as the Sun. So which finding, if true, would most directly weaken? So you want something that's opposite. So you are looking for something that says that the planets do not contain the same gas and dust. So if you look at this, most stars are made of hydrogen and helium, but when cooled, they are revealed to contain small amounts of iron and silicate. Okay, so this kind of supports it, because it kind of says they are mostly made of hydrogen and helium, which is dust. So this is gone. A nearby host star is, it comes up and says when they are cooled. So this is gone. And a nearby host star is observed to contain the same proportion of hydrogen and helium as that of the Sun. Well, they said host stars, so there could be other host stars around. So this would support it, but you're trying to weaken it. And remember what you're looking for. You're looking for something that is going to weaken, because if you keep looking for something that is going to strengthen, you're going to choose one of these answers. So make sure your mind's alert and you know what goes on. Evidence emerges that the amount of iron in some rocky planets is considerably higher than the amount in the host star. So they said equal or smaller. This is a maybe. And the method for determining the composition of rocky planets is discovered to be less effective when used to analyze other kinds of planet. Okay, so the method used for determining the composition of rocky planets in our solar system. Rocky planets in our solar system are composed of the same materials. So now you could weaken it if you said the composition of rocky planets is discovered to be less effective when used to analyze other kinds of planets. This would kind of go along with it. Choice D is less effective when used to analyze other kinds of planets. So here, let's get what's going on. They're talking about the method, less effective, other kinds of planets. Take this off. Other kinds of planets. And guess what happens? less effective if they said when used with host stars. And if they said that, D would be your choice. Since they didn't, choice goes to C. Make sure you are reading every possible part and detail of this information. They didn't get into this. Your answer is C.